Hey guys, this is Horner, and we're going to take a look at projectile motion free response question F2. And in this one, we have the surface of a turntable, and it's covered with a rough substance so that things don't slide off. And there's a coin that we put on that table. You'll see the coin right here. The maximum strength of static friction between that surface and the coin is FF. And a student uses a mechanism, which they don't show, to increase the speed of this turntable. Three students really want to know what the relationship is between the radius, so that's this right here, at which the coin is placed, and then the period for which it spins. So remember, period here would be, so let's go ahead and put period is the amount of time it takes for it to go around in 1 second. So we're not really sure about that period. Students think different things. So the first student says, I think that T will increase as R increases. So if I move the coin further out, then the period will get bigger. I think T will decrease as R increases. So if you pull it out, then the R will get bigger, but the period will go down. And then student C says, I think that T will not change even as R changes. So which student do you believe that is the most correct hypothesis? So for this one, the answer key they've chosen student A because they say that essentially you could look at the two. So here we go. It's we have an equation that relates R and T to justify our answer. So to do that, we're going to start with the sum of the forces in the x direction, and that would be just mv squared over r, because that's mass times the centripetal acceleration. So probably we should have started with this equation. Then we can do this one, and now we see the only thing pointing to the left or right is the force of friction, so that's equal to mv squared over r. We know that v, which is the speed of any object that is rotating, is 2 pi r over the period. And now what we're going to do is we're going to plug this thing in for v. And when we do that, we have to square the 2, square the pi, square the r, and square the t. So here is 4, which is 2 squared, pi squared, over t squared. And then we also had to square the r, so we did that. And then that is over r, so that r is this one here. And then our mass we just put out front. You can cross off one of the r's, the r squared here, cross off the r here, and you're left with the force of friction is equal to 4 pi squared mr over t squared. So r and t squared must increase together in order for that fraction to keep the friction the same. And so that is why we need to worry a little bit about what's going on. The students have access to a turntable and a mechanism that causes it to rotate at different rates. So 3 coins made out of different substances are put on there. They all have the same mass and the same radius. You have a ruler and a stopwatch. In the space below, they want us to go through just a procedure that allows the students to follow in order to make all the measurements. Make sure you use any methods by which experimental error can be reduced. So we know that to reduce error, so this is one of the points, just do multiple trials. If you put that in, they'll give you a point regardless of how bad your procedure is. We're going to place a coin at spot 1, that is the smallest radius. We're going to increase the period until it slides off. And then we're going to measure the radius with the ruler and period of rotation with the stopwatch. If we do that and we do multiple trials to reduce error, they would give us points for that. So now you have a different set of students with the same procedure, follow a different procedure, make measurements. After making those measurements, they construct this data table. So they want to know, out of these 11 trials, which one should you use? You want to use the one with the same coin. So you can use 2, 4, 6, 8, and 10. You could also have used 1, 5, and 9, or 3, 7, and 11. But the one that is iron, Fe, is iron. So I know it says steel, but that's iron. So what you'll notice is 2, 4, 6, 8, and 10. All of these have the same metal, and that one has the most trials, so that's why we chose it. In part 2 here, you'll see that it says use the trials that you indicated in part CI to plot a graph. So I went through and plotted the graph with those different points, and you'll see that the shape of this is root. So this guy right here is got a root shape, and therefore it's got to be a square root relationship. And the student looking at that graph suggests that the radius and period are directly proportional. The only way they could do that is if they started at the origin and made a straight line. They don't do that. And because they don't do that, we're going to say no. Explain your answer using either the graph, the data table, or the equation. And we're going to use the graph. We're going to say the relationship is square root, and it is not a straight line through the origin. And that is the end of that problem.